Incredibly interesting. The two main projects that I was lead contributor on back in the day was the MAT tracking engine, and which has some of the most number of lines of code that in our company still exist today, and also the API. And so as we continued to grow, the main challenge was, well, at the beginning, the default was to develop with monoliths, and we thought iteration would be easy this way. As we progressed throughout the years, this was not the case. Maintenance was very challenging. And so we started to take our monolith, as most startups did at this time, and move towards a service-oriented architecture. And this is exciting, except for one of the main challenges with the service-oriented architecture is the services are still relatively easy. Most of the time, your consumer is the monolith and not the actual microservice. And so you can have a few different teams developing smaller services, and the contracts, they can kind of vary because it's the monolith that still kind of maintains everything. So the exciting part was, well, if we know where we're going to progress, we're going to continue to go down this route of taking our big monolith app, break it off into smaller and smaller services, which will lead us. So the challenge and the most exciting part was, well, how can we break this linear progression? How do we get from just rewriting specific services to get to a real microservice architecture? And that's where the fun began. But the interesting thing is, well, as soon as you get to the microservice architecture, there's kind of some of these other fun topics come up. So if you're developing small services, do you prototype and throw away, or do you prototype and iterate? Well, if you start with Go, then maybe you can prototype and iterate, but if you just develop with Go, are you actually including everything you need to in the base service so that you can continue to iterate? One of the other interesting things is, if you are going to develop a new service, does it make sense to just do it in Node or Ruby? I know we have plenty of developers here that their default still is Node or Ruby. And not that there's anything wrong with that, but the challenge for the Go community is we got to somehow figure out how can we change that default? How can we change the default prototyping language to be Go? And then on the flip side, then you have we have a few teams that are using Go Swagger, and this is kind of the concept where you do have Go Swagger's attempt to provide a very, very structured spec for creating a service. But if you actually start looking at some of the Swagger spec files that different teams are generating, they still differ. They differ on the mindset of the engineer who decides how many status codes they want for one service and the format of the error message versus another one. So over the past 8 months, I got the opportunity to lead up developing a new product here at Tune called Multiverse. And one of the things that we decided to do was, how can we do it completely differently? And how can we start with a microservice architecture, experiment with it, and then figure out where we can go from there? And so the fun thing is, we're on this journey. One of the interesting things that we experienced was, well, if we are doing microservices, then it kind of amplifies everything that you have to do across any service you develop. A, you have to have consistent contracts between all of your services. B, most of the time you're deploying 10 to 20 times more services than any of your previous existing infrastructure. So with that, we took the opportunity to develop some tooling around creating effective microservices, and that's what Adam and Leland are here to share with you guys today on how we've developed microservices here at Tune.
Thanks, Lee. All right, so starting off, yeah, I'm Leland, and I'm
Adam. I'll be doing most of the demoing, and Leland's going to be doing this part of the presentation.
Yep, so let's get started. Our project has been trying to make microservices great. So to start off, though, like, what do we mean? Not necessarily everyone here is on the same page. So what are microservices? Microservices, for the purpose of this presentation, we mean Microservices are a response to the design problems that come with a monolithic architecture. And, well, defining microservices in terms of monolith, what is a monolith? What do we mean by that? In software engineering, a monolithic application describes a software application which is designed without modularity. And I'd like to add single process. So as you can see kind of in the diagrams, these are the two aspects that you end up with. A piece of software that is composed of a bunch of different components, each of which kind of interacts with all of the others, and you end up with a snarled mess. Something that doesn't really make a lot of coherent sense as to why is this talking to this but not this other thing, where are things located, and all of your components run within a single process. The problems that arise with this kind of monolithic architecture are, monoliths are, to start off, they're really easy to create, but once you have them, they are ever harder to expand and to build upon. It's really easy to start with a hello world, and you just keep adding business logic and keep adding features until, hey, you've got what you want. Things are doing what you want them to do, but you have a mess on your hands. You end up with accidental coupling. You end up with interwoven spaghetti logic that just kind of is not really the best. And once you have such a mess, bringing other engineers on and saying, hey, I need you to understand this. I need you to, after you understand it, take it and change it and make it different in this way. That can take weeks or months with a really large and complicated monolith. You end up with situations kind of like this diagram where, your architecture looks like a plate of spaghetti, and asking questions like, where is the customer in this mess, yields answers like, well, it's kind of everywhere. And that's how it works for any bit of introspection. Everything kind of is everywhere. And it's not really very excellent. So monoliths, not great, hard to work with. What are microservices then? Microservices means services in a microservice architecture are processes that communicate with each other over the network in order to fulfill a goal. So unlike the previous diagram with all of your various components running within one process, a microservice architecture, we say each of our components runs in a different process, which may or may not run on separate units of computing, and they coordinate with each other over the network using clear API contracts and with clear separation of concerns. Microservices are great because they solve a lot of problems that you end up with, that arise with a monolithic code base. You get these small and comprehensible parts that an engineer can take and in a day understand and modify. It's easy to scale these small parts horizontally, and when you have a network of these small parts, if any one fails, the entire system does not fail, and it is more fault tolerant. These are all things we want. This is great. But microservices have some downsides as well. Because you have to create so many separate services, there is overhead involved. You end up with lots of boilerplate for things like transport, for code, for logging, for metrics, for tracing, all of which you need, because without them, you end up with a black box that is not easy to understand. Because when you have a microservice architecture, you have shifted a lot of your functionality into the connections between your various microservices. And in doing so, you can't leverage existing tooling to understand and inspect what is going wrong. You can't just hook a debugger up to your one process that does everything and say, I see logic flowing through here like so, and I see that this is an and it should be an or, and that's why it's going wrong. Great, I can fix it. You can't really do that when logic is flowing across 4 different servers and 4 different processes and 3 databases, and it's just like you can't use existing tools to do that. So you have to have really good logging setup, metrics, tracing, health monitoring, rate limiting, all of that. So, you know, there are downsides. Before we get into what we did in our approach, we do want to just acknowledge the other kits and tools that exist for building microservices in Go. GoKit and GoSwagger and Gizmo and Goa are all really interesting, and you should all look at them because they've got a lot of cool stuff going on. But they didn't fit our particular needs because each one of them suffered from one of these 3 aspects of either limited transport support, so they were limited to either something like gRPC or only Thrift or only HTTP and JSON, which we don't particularly want. That does not meet our needs. Or they require that every single microservice have a ton of repeated code for doing the same logging, the same metrics, the same service discovery over and over and over. And that is also utter drudgery and a place for many small mistakes to creep in. And none of them really had exactly the mechanisms for keeping documentation up to date so that what your service does is matching up with what the documentation says your service does. So our approach has been to create Truss. With Truss, you define your microservice in one definition with gRPC, and from that, Truss generates documentation. In a really nice format, it generates a Swagger /OpenAPI spec. You get a microservice that is generated for you that is GoKit based, that has transports for HTTP JSON and for protocol buffers, and that microservice has logging and metrics and all the rest built into it out of the box. All you have to worry about with Truss is business logic. Everything else is done for you. And it all works like out of the box. It's awesome. So before we go on, we do want to just acknowledge why did we go with GoKit as the basis for our microservices that we generate. Basically, GoKit was the only, or was the best fit for this. It didn't have all the features that we wanted, but we really liked that it was based on gRPC and protocol buffers, and it had support built into it for all the different transports that we want of HTTP, JSON, gRPC. It also supports others like Thrift and so on. We'll probably be adding support for that at some point. And it includes default tooling implementations for logging, metrics, service discovery, the rest. So GoKit was, of all of the frameworks and kits and libraries available, it was the best fit for what we wanted in terms of being able to generate a microservice. So having said all of that, and explained Truss is awesome and solves all your problems, I'm going to give it up to Adam to demonstrate using Truss to build something awesome.
Okay, so real quick, before I actually go into doing the demo, I'm going to do an overview so you can all follow what I'm going to build. So we're going to build a really simple 2 microservice chat service, service, I guess. So there's going to be a speaker which will say things to the clients. So the clients are those yellow smiley faces, and everyone will say things to the amplifier. And so to make this fun, the amplifier just adds an exclamation point, and the speaker just repeats whatever it says to all of its clients. So it gets it gets in Truss, it says Truss, and then it says Truss to everyone. And then, so what I'm going to do is I'm going to define a service with gRPC. I'm going to run our Truss binary on that. We're going to look at the documentation, implement the business logic, behold the system working, and see that microservices are great again. So let's do this. So is there a microphone stand? I didn't realize I'd have to hold one. Are you going to hold it for me? How nice. Yeah, let's do this.
Let me hop on this side.
You need a chair?
No.
Okay. Yeah, so let's do this. So I'm going to go into my speaker folder, and I'm going to make this guy. So we define our syntax. These are protocol buffers. If you don't know protobuf, you can go to grpc.io and look at how it's implemented. So, oh, whoopsie, sorry. Yes, I can definitely make it bigger. Let's see, so much bigger. Doop, 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 doop. Okay, it doesn't look quite the same on my screen, so I thought it was big enough. There we go. I think that is good. So here I am importing a file that will allow us to do HTTP annotations so we can get both protocol buffers and HTTP JSON. I'm going to define a request which is going to be broadcasted to so this is the say request is going to contain a message. So say request, message to be broadcasted, which is a string. And then we're going to define a response, which is returned to the client. And this tells the client whether or not the message was broadcasted. So the speaker is going to be a service which has a method called say, which stores the message, and it will be set out later. So say request returns say response, and we're going to define the HTTP JSON route, which is going to be post on the route say. So, and the message will be contained in the body. So option, gRPC. So post, it's going to be say. Everything's going to be contained in the body. And then, there we go. And let's run Truss on this thing. So service path, and now it's building the service. And so what it generated was a folder called service, which has a bin folder, which contains the binaries. Clients, which has a client handlers. It has some documentation as markdown. Big do not edit folder with generated code, generated non-touching code. And the server folder with the service.go, which contains the business logic. And you can see our original speaker.proto file. So if we go into service, and we go into the docs first. And I'm going to render this as HTML. And then I'm going to just open it. So we can look at it real quick. And oh, look, there's documentation with all the comments in it and stuff. Awesome. So now let's implement some business logic. So if we look in this service folder, there's some generated code with imports. And down here is this method the method say, which takes in a say request and returns a say response. The response is going to have the field accepted, which is a bool, whether or not it was accepted. And so for this, I have written our data storage already, which I'm just going to import. It's just a queue, so everything that gets sent in will be stored in a queue, and then whenever someone wants to get a message, they will look into the queue. So let's see. So queue has r/q. Yep. And now the queue, we're going to just store as in-memory data, q, q.q. You that know Go will know that, right? So in-memory data dot push, and we're going to just push in.message. So in.message is defined in the protobuf file. I'm just going to show that right next to it real quick. So as you can, so right here, we have, let's see, I'm going to make this big too for all of you. So in is a say request. So in.message represents this string right here. And then our response is going to have this accepted value. So just for this example, accepted true. So it takes in a thing and it stores it and just says, yes, we did store it. So then if I run Truss again on speaker.proto, it says that these methods already exist, so it's not going to blow them away. And now it has built our service with those methods, or with that method. But that doesn't really do anything. I only implemented one of them because I wanted to show off the cool thing of, oopsie. I wanted to show off the cool thing of when you edit your definition file with more stuff, it will generate new methods, hook them up for you, and not destroy any of your already created business logic. So we're going to now implement another method. It's going to be listen, which accepts a message ID and returns the message with that message ID, as well as the latest message ID, so the most recent message. So RPC, listen, is going to take a listen request and do a listen response. The route for this is going to be get, because we're not changing state. And non-specified fields will be in the query. So I'm going to just be get, it's listen, and that's it. And it will assume that all of the fields are in the query. So listen request requests a message by ID. So here's the message ID. And then listen response is going to return the message as well as the latest message ID. So latest message ID, string with the message, and there's that. And so if I run truss, speaker.proto, so it says rendering template method for this, or rendering template for this method. So now, if we look in the server, we'll see the same file we edited a moment ago, and we'll look down. Oh, yep, here's the same method. Yep, in-memory data push. But if we go down, oh, look, here's a new method that we just defined. So this method is even easier to implement than the last one. So the latest message ID is just going to be that in-memory data dot the length of it, because that would be the final one. And then we are going to do in-memory data dot read this in dot message ID. So the in message ID, which and then zoom in. There we go. So just so you see, message ID right here and this message ID are the same thing. And then we save this. Let me close this other one. So we return the latest message ID and we return a message. So now if I rerun Truss, it will build our speaker. And then I'm going to build the amplifier, which I mentioned. So amplifier. Oh, well, I'm going to remove this one because I want to do a new one. Fire.proto. So again, we have to do like its package and then this import again to do those annotations. And so the service amplifier will have also a say method, which takes request response. And this is just going to pass along the message with an exclamation mark at the end. So it's going to be a post to route say, and everything's going to be in the body. And let's define the say request, which will just have a message. And then the response, which will have a bool of whether or not it was accepted. So truss. Okay, and so it's going to generate this microservice. And if I were to tree it again, it would look very similar. And we're just going to implement the logic for this one. So this one's a little bit more complicated because this is going to interact with another microservice. And we have been focusing on generating single microservices. So I have to do some imports to get this guy to work. So let's see. So this import represents the gRPC connection to the speaker microservice. These are the response and request types of the speaker, and this represents like the actual methods of the service. And we also have to import gRPC and time for 2 methods I'm going to do. So here's that say method that we defined in the amplifier. This guy, before I get into like how we connect to the speaker, I'm going to do the logic for the say method. So if we have no speaker, then the speaker is going to be connect to speaker at this hard-coded port, because that's easy to demo. I will write the connect speaker method in a second. So the speaker request, because we're going to ask the speaker for something, it's going to be of speaker type .say request, and we want the message to be the message we take in plus an exclamation point, because we want it to be amplified, louder. And so then the speaker response is going to be what we get when we say to the speaker this request. And then our response is going to be of our type say response, and we're just going to echo back what the speaker said, and then we'll return this up the tree. So now I'm going to write that speaker connect method, and I know this is taking a while, so I'll do this guy real quick. Boop, 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 da la la la. Yep, so it takes, it takes an address, and it does all this stuff. Yep, okay, we got it. Returns the speaker. It builds, right? Yep, builds. Okay, let's run Truss on this. And it will build everything. And then after this, I'm going to launch all the microservices with this orchestration script, which basically just launches them on separate ports with the port I hard-coded. So do it. Okay, they're launched. And now I'm going to run the web server, which is our listener. And this basically just connects the microservices together, and it has some JavaScript which pulls continuously from the speaker. And when you type, interesting. And when you type something into the text box, it's going to give that to the amplifier. So now I'm also going to connect this up to a domain name, which is let's do it live. Okay, and now if you connect to comp.adrenal.in:1337, you should be able to, exclamation point at the end. Woo! So people should connect to this. Comp.adrenal.in:1337. If you type something in, it will get sent out to everyone with an exclamation mark at the end. So someone should do something. I have no filters, so like, Leland, stuff is coming in. So in this short demonstration, I built up 2 microservices, an amplifier and a speaker. The amplifier connects to the speaker. I can actually just show that diagram again real quick. So a person says something, it goes to the amplifier, which gets an exclamation mark added to it, which gets sent to the speaker. The speaker stores it in a queue, and then when the client requests, it requests basically message 0, and if it gets a message that's a message ID in the future, it will just keep requesting messages until it's up to date. So let's take a look at that if people are saying things still. Yep, oh wow, bold text right here. I think like probably, what do you call those, emoji and things will work because it's Go and we have Unicode support and all of that built into strings. But, so yep, that's the demo. Yeah, so let's see, what is the next slide? Well, that was surprising. So Leland's going to, woo! So Leland's going to cap off the presentation by describing a little bit more of what just happened. Man, those are loud.
So, as you guys saw, Truss, really cool, awesome. Yeah, it has some great features like Truss does not destroy your business logic when you rerun Truss. A bunch of other things that we evaluated totally do that. That's not appreciated. Truss is great. It's backward and forward compatible in that HTTP JSON is supported as a transport, and so are protocol buffers. So if you want to have your backend run on protocol buffers and save a bunch of CPU on not having to marshal to and from JSON all the time, it's like 10% in production can be up to that.
The demo was the microservices when they communicated was over protocol buffers, but then when it interacted with the web front end, that was over HTTP JSON, and both of those were just pre-generated. And when I was writing the demo, we hadn't had HTTP transport fully working yet, so I was just doing gRPC. And then we got it working, I reran Truss, and I automatically had HTTP JSON transport under the hood for free. Yep.
Yeah, so that is the next big thing, which is as Truss improves, your microservice improves along with it. As things get better, you just get more stuff for free because, Truss is awesome. So yeah, from here, our roadmap is we need logging metrics and service discovery to actually make its way into that. It is not entirely finished yet. Currently sitting in pull requests. We even code reviewed all of them. We just didn't merge because we were preparing for this presentation. Our automatic HTTP transport generation, which you saw, and an API Explorer that you get from the fact that we generate a Swagger/Open API spec, which also allows you to create clients that can interface with your Truss-generated microservice in like any language, because OpenAPI is an awesome community, so it's super interoperable. And and we're going to open source this by September 1st. So yeah, Truss, it's going to be awesome. Wow, okay. So, from here, any questions? Martin.
We should try to do this.
I noticed that in your auto-generated code, you're implementing methods on the structure itself, not on the pointer to the structure. So, yeah, so why is my question?
I'd have to like this. Whoa, JavaScript.
Oh, yeah.
I'm not 100% sure what part of the code you were mentioning there.
You want me to
Yeah, let me pull that up real quick.
You may want. So the question was, in the auto-generated business logic, there were methods that we saw, and the receiver in that case was not a pointer to this. It is just, yeah.
It's just I can do. Yeah, so I understand. So it could have. It is just to implement the service interface currently. So if the basic service had like it was what do you call it? It had things to modify, then that would be good. And also this is like, currently we are moving very quickly, so it was just kind of, it doesn't fail without that. But that's a good thing to look into. Currently, it's just purely to implement the service interface, which is, where is the service interface specified? Oh yeah, it's specified at the bottom. The service interface, say and listen, and so we have to create a concrete type, which is basic service, and so these methods, the method say and the method listen make it so it implements the service interface, which is like, it's part of how GoKit does its organization. Though these could be pointers, and then the basic service could have types could have fields within it. That is a good question though. Yeah, thank you for asking. More questions?
Yeah. Any more questions? How long did this take to build? We started
building it 3 weeks after May 20th. We started building it 3 weeks after May 24th. So when is that?
I like almost exactly 2 weeks into June. So like June 14th would have been like our first commit probably. And and now we're here. So yeah, it took that long. Yeah, in the back.
The first question was I really typing? And the answer is no. like I hope you realize that at some point. But it's if you want to know the thing I used, it's called Keyboard Cat. If you Google Keyboard Cat Vim plugin, you'll see that. But what was the second question again?
The second question was, in the follow-on to that, is there a word per minute minimum for working at tune?
Is there a word per minute minimum for working at tune? Well, if you have Keyboard Cat, your word per minute goes up by a lot. So you can work at tune if you use Keyboard Cat, right? Yeah. No.
Yeah. Well, thank you.
So one of the problems that I think the big libraries have is people tend to be very opinionated about like how their logging framework is going to work, whether or not they're using like syslog or they have some other third party that they're doing log aggregation with. How are you guys going to build like unified logging for your system and still allow it to be like plug and play so that other people can implement their own logging interface?
That's a really good question.
You should repeat the question for the video.
Okay, yeah, so to repeat the question, how are we going to build a logging... When people have really strong opinions on how they do logging in so many different ways, how are we going to build an extensible logging system that makes everybody happy, that allows everyone to choose their various solutions and it fits in wherever? And the answer is we don't quite know yet. Like, we haven't gotten there.
Been working on HTTP traffic.
Yeah.
That's one of the reasons why we chose GoKit at the beginning, is because they go on this whole idea of middlewares, and so they already support multiple frameworks for logging. So we're hoping that we can support as many different logging libraries that GoKit does, but we're still working on figuring that out.
Cool. So yeah, any other questions?
So for the handlers that are going to be calling this RPC service, how do you handle things like authorization and that?
That is so. To restate.
Okay, so the question was, how are we handling authentication? Currently, one of the ideas is to have a service that does the authentication, and that would be in the middle between, you would have a service that does authentication, which would be at your gateway layer. A request comes in, it gets authed, and then it gets into the network of microservices where it doesn't need to be authed at every point. Though this is also a thing we're still exploring. We're currently getting our transports and things working, so when it goes open source, adding issues for things like that will be helpful.
Yeah. Another question? Yeah.
Have you had a chance to benchmark the generated code plus business logic against other similar services like gRPC Go or the handlers that you get with GoKit?
The question was, have we had the chance to benchmark our generated code against the code that you get from, say, implementing an equivalent microservice in just GoKit or with some other some other toolkit? And our answer is we have not done that yet. Now, having said that, we are pretty sure that we're really close to, performance-wise, to just a naive implementation of a microservice in GoKit, because our generated microservice is extremely close to a naive microservice in GoKit.
If you go on to GoKit's GitHub and you look in kit/examples/add SVC, our generated service is very, very similar to add SVC. So whatever performance that has, I imagine ours will have similar, though benchmarks will be a thing for us to do and add that so we can compare our services to other generated services. Yeah.
Once again, you should raise an issue on the GitHub when this goes open source. We would really appreciate it. Yeah. Any other questions?
So in my introduction, I mentioned that past 8 months we've been working on launching a new product here at Tune called Multiverse. The whole product is developed using GoKit, and so the challenge for these two individuals was to take what we've developed for Multiverse and add automation around it. So as we continue to add new services, we want to go back and improve the existing services that we already have launched. It's much easier and 1,000 times more efficient. So yes, their next target is to take our existing Multiverse product and run Truss against it.
Any more questions? Let's see.
Would you consider making the scaffolding feature of this separate from the rest of the feature? It's like the bit that generates the code and we appears in there for users, so that people can potentially mix both this and GoKit events?
Well, so the question was, could we remove the scaffolding, the part of our application that does scaffolding, and then you could plug and play like other microservice frameworks? The answer is our thing is pretty much just scaffolding. It builds up a GoKit service very specifically. So you could it basically just does scaffolding. It does the scaffolding. It takes a protocol buffer file, it parses it, and then builds up a structure which represents an AST, if you will, of the protocol buffer file, and then templates out a microservice, and it templates out documentation, templates out a Swagger / Open API file, and then it builds the microservice. And if it finds pre-generated code already on disk, then instead of just obliterating it, it reads in the Go AST of those files and modifies the AST to add new functions if they were defined in the protocol buffer file. So it kind of is just scaffolding. Because it is going to be open source, you could fork it and then change all the templates to be of another microservice framework, but that would be almost as much work as rebuilding it all, probably. Yeah, wrap. Okay, so we've been told to wrap up. Sorry, there are a couple more questions out there. Thank you very much. Yeah, Truss makes microservices great again. Let's see, can we switch to the thing? Yeah. No? No?
Thanks, guys. That was fantastic.